Hi everyone, it's Coach Fred, and today in class we were discussing the difference between a ratio and a rate. And it took us some time to really recall ratios as a comparison of two or more quantities. Remember I said that we write ratios, a couple of you said as a fraction, sure, like 1/2 or 3 to 2. We could use colon, we could even write 3 to 2. Um, and ratio compares one or two or more quantities. And then we tried to come up with a definition for a rate. And so I guess the best one I can come up with is a rate is a type of ratio that also involves quantities, but with different units, such as miles per hour. And we talked about the fact that rates are expressed with a denominator of 1. So like if I said 50 miles for every 1 hour, that is a rate. That's actually a rate of change. But every time I ask about rate of change, everyone says slope. Well, 2/5 a slope, that's a ratio. As a rate of change, it would be 2/5 over 1. Remember, I said a denominator of 1. And if it's a rate of change, we actually have to express it with the units. So we're going to be spending some time talking about linear models, and I think it's important for us to really understand the difference between a ratio and a rate. All right. Okay, so let's look at a word problem. Sometimes when we're writing linear models, a word problem will involve a constant rate or speed, and it will give a relationship at some point in time between each variable. It's not going to always be so easy, so sometimes we have to turn information into coordinate points to help us. So let's just take a quick remember that when I get stuck on things, I want to be able to look at a function 4 ways: symbolically, graphically, numerically, and descriptively. And I want to be able to work my way through all 4 of these to help. So let's see what we've got. Marty's spending money at the average rate of $3 per day. Okay, so it says the average rate of $3 per day, so that's giving me an average rate of change, so a slope. He's spending money, so in this case, it's going down by $3 per day. So $3 per 1 day. So you can see it as an average rate of change or a constant rate of change. Now, because we're going to put it in an equation, we're going to let it behave like a slope, so we're going to write it as -3. All right, and then it says after 14 days, he has $68 left. The amount left depends on the number of days that passed. So that's telling me that my x is days, and my y is the amount in the account. Okay, so now I have a verbal description of what's happening here. I'm actually going to put it on a graph because I'd really like to see what's happening. So I have time and I have amount of money. And so we started at, actually we don't know what we started with, so let's see what we start with. So I need some more information so I can fill in my graph. All right, so after 14 days he has $68 left. Well, if I know x is days and y is the amount in the account, I can turn that into the coordinate point, 1468. All right, here's the great information. I have a point, 1468, and I have a slope, -3, so I can use point slope to write an equation for the situation. All right, so that would be y minus 68 equals -3, x minus 14. Now, when we're writing linear models, we really want them in the y equals form or f of x equals form. So we're going to put this into slope-intercept form. So I'm going to distribute my -3. And that's going to give me y minus 68 equals -3x plus, what is that, 42? And then I'm going to add 68 to both sides. And so y equals -3x plus 110. Okay, now I have more information. So I can see that my y-intercept is 110. So that's right here. And I'm going down $3 a day all the way down until I get to here. Okay, so it says use your equation to find the amount of money he began with. Well, wouldn't that be our y-intercept? Wouldn't that be when our days were 0? So I can see it clearly in my equation. My starting amount was $110. Okay, so let's walk through. We're given a descriptive representation of the function. We were able to write a symbolic representation of a function, and we were even able to graph it. So let's talk about numerical. Numerical is when I'm looking at ordered pairs. So I actually have an ordered pair on this graph, 1468. So we'll put it right here. I have another ordered pair, the y-intercept, and I know that that's 0, 1, 10. I wonder if there's a way for me to find this ordered pair. Well, that's the x-intercept. And I've been big on you guys understanding the x-intercept is where y was equal to 0. So if I did want to find that x-intercept, I would set y equal to 0 and solve for x. I'm going to ask you to go ahead and do that and bring that answer to class tomorrow. Let's see who's right. All right, let's see if we have time for one more. What about, instead of giving you a rate, a word problem gives you two relationships at different points in time between variables? This might look familiar to some of you. It's the question some of you skipped on the last test. All right, so biologists have found that the number of chirps some crickets make per minute is related to temperature. The relationship is very close to being linear. When crickets chirp 124 times a minute, it is about 68 degrees Fahrenheit. When they chirp 172 times a minute, it's about 80 degrees Fahrenheit. All right, so let's talk about that. We got to figure out what's x and y. And I didn't tell you. So I always ask myself the question, what depends on what? Because y depends on x. So does temperature depend on the amount of chirps, or does the amount of chirps depend on the temperature? Hopefully you're saying the amount of chirps depends on the temperature. So that means that the amount of chirps is my y, and the temperature is my x. All right, so again, I have two relationships at different points in time, so I actually have to make them and turn them into coordinates. So when crickets chirp 124 times a minute, it's about 68 degrees. So that would be 68, 124. And then when they chirp 172 times a minute, it's about 80. So 80, 172. Okay, so I have 2 points. I want to write a linear function. The minimum I need to write an equation of a line is a point and a slope. Don't have a slope, so I need to calculate my slope. So let's see. Gives me 172 minus 124 all over 80 minus 68. So let's see what we got there. All right, so 172 minus 124 is 48. And 80 minus 68 is 12. And 12 goes into 48 4 times. Okay, so I get a slope of 4. As a rate of change, that means that there will be 4 chirps for every 1 degree increase in temperature. 4 chirps for every 1 degree increase in temperature. All right, so I have now a point and a slope. I'm going to pick either of the points. I'm going to actually pick the 80, and I'm going to plug it into point slope. So y minus 172 equals 4 times x minus 80. Moving into y equals mx plus b is going to give me y minus 172 equals 4x minus 320. And then I'm going to add 172 to both sides. Okay, and that gives me 148. So y equals 4x minus 148. All right, so now it wants us to interpret and ask a question. How warm is it when the crickets are chirping 150 times a minute? That's the y, so I'm going to set it equal to 150. And find out how warm it was. All right, so that gives me 298 equals 4x. And I'm going to divide that by 4, giving me 74.5. All right, guys, I'm going to stop there. Again, I'm going to ask you to really think about what a rate of change is. Maybe even do some research on it, and we can discuss it on Monday. Have a great day.